Welcome to the last talk in the Neo4j deep dive track. I'm going to be talking about NoSQL Polyglot Persistence, some Neo4j tools and integrations. So my name is Will. I work on the developer relations team at Neo4j. So I talk to a lot of Neo4j users, and this is a common question that I get: does Neo4j work with fill in the blank? And this is really a valid question when you're evaluating a technology. You have your existing stack, and you want to know how that this new technology that you're thinking about adopting fits in with that. So does Neo4j work with my favorite language? Well, we heard from Nigel earlier today, who talked about the Neo4j drivers, and we know that yes, Neo4j does work with my favorite language. Does Neo4j work with my framework? Well, we heard earlier today from Lyon talking about Spring Data Neo4j and how Neo4j integrates with Spring Framework. What about other databases? Can we move data back and forth? What about Docker? Can we deploy Neo4j with Docker? What about frameworks like Spark? And so these are some of the questions that I'm going to answer in the next 30 minutes, talking about some tools and integrations that are out there for using Neo4j. So polyglot persistence is this idea of using multiple databases to power a single application. And so a typical polyglot deployment might look like this. Our application talks to multiple databases. Internally, we make ad hoc analytics, BI queries to our databases. And it could be that we have this deployment for legacy reasons, that we're using multiple technologies. Or it could be we're trying to take advantage of polyglot persistence. So I think Martin Fowler was one of the first people to talk about polyglot persistence and taking advantage of the strengths of different database technologies. Because we're working with different data in different ways, and each database is optimized for working with data in different ways. So consider a typical e-commerce application. We might be using something like Redis, key value store for the shopping cart, where we're interested in very quick reads and writes. I don't need to do complex queries on the data that I'm storing in Redis. I have the ID for my shopping cart session, so I can pull that out very quickly. We might be using a document database for our product catalog, where we're storing lots of information about our products, and we need to do things like text search, return lots of JSON to populate a view in our application. And then for recommendations, we might use a graph database like Neo4j, because as we heard from Nicole just now, Neo4j is great for generating recommendations. So this type of polyglot deployment might be typical for an e-commerce application. But the benefits of polyglot persistence don't come for free. There's some added complexity here. And so that's what I want to talk about, is some of the tools we've been working on at Neo4j and also from within the community that help working in these polyglot environments a bit easier. So the first challenge I want to talk about is data sync. So if we're using multiple databases, how do we move data back and forth, keep the databases in sync? So typically, in a polyglot deployment where, let's say, we're introducing Neo4j, might look something like, or we might have three options here. So the first is to migrate all of our data into Neo4j and all queries going to Neo4j. Somewhere in the middle of that is migrating just a subset of that data. So graph data goes to Neo4j, our non-graph data goes to our relational database, document database, whatever. Graph queries go to Neo4j. Non-graph queries go to our other database. And then another take on that is we can duplicate a subset of the data. So all of our data goes into our relational database, into our document database, whatever, and we're only interested in moving the graph pieces of those, the relationship pieces of the data, into Neo4j. So then our graph queries go to Neo4j, non-graph queries go to our other database. So let's take a look at an example application where we've taken the latter approach. So we're duplicating a subset of the data here. So this is a course catalog for an online platform for courses. So the user here is searching and browsing for courses they might be interested in. The functionality we need to provide, well, we need text search, we need filter by category, date range search, and we need to return lots of text, maybe JSON, images to populate this view in our application. So this might be a good use case for a document database. So let's say we'll use MongoDB for this. But something's missing in this view. Like, what about Bob, right? So this is all being done in the context of the user. I'm logged in. The site knows the courses that I've taken. It knows how I've interacted with the site, maybe my social graph, how I've interacted with other users on the site. So we really should be able to provide personalized recommendations to this user. These are courses you might be interested in based on other courses you've taken, based on how you've interacted with the site. And we know Neo is great at generating recommendations. So for this, we might want to use our document database for our standard product catalog features, and Neo4j for generating recommendations. So the question is, okay, if we're using Mongo to store our product catalog and information about courses the user has taken, how do we get that information into Neo4j so that we can do these graphy recommendation queries? So the first tool I want to talk about that makes that a bit easier is the Neo4j Doc Manager. This is a project that is designed to automatically sync documents from MongoDB into Neo4j. So it converts from the document format to property graph model. There's information for this available online for getting started with some examples. Just a really quick high-level view of how this works. It's basically tailing the Mongo op log, which is the transaction log for Mongo, so it's notified of any updates to Mongo. Those are then converted into Cypher and streamed over to Neo4j to keep Neo4j updated once the data in Mongo changes. So you might ask, well, how can we convert a document into a graph? So let's look at a simple example of how we do that. So here's a document. This is describing a talk at a conference. So we have one root level document. We have a couple of nested documents. So we have a session subdocument and a speaker subdocument. So if we were to insert this into Mongo using the Neo4j Doc Manager, this is the graph we would end up with. So we would have one node which has this talk label. This is from the talk collection in Mongo, so it grabs the label from the collection. And then we have two nodes for each of the subdocuments, speaker and session, with a relationship to the root level document. And you can see we're storing properties from the root level document and from the nested documents on the nodes as well. So that's how we map documents to graph. This is available as a Python command line application. So pip install Neo4j Doc Manager, and you're good to go. If anyone's interested in learning more about this, I'll be doing a webinar sometime in the next few weeks talking about using Neo4j and Mongo, and we'll actually walk through building that course catalog application. So definitely look for that if you're interested. And then I also want to mention that we have, the community has something similar for Couchbase. If there's any Couchbase users, that one of our community members, Lorenzo from Loris, he's here today. He was talking about their JDBC integration that they've worked with earlier today at a lightning talk, so hopefully you caught that. Okay, so projects like this that's great, but this introduces another problem. So now I have two databases that I need to deploy. I have this Python service that needs to listen to both of them. This complicates my deployment and operations quite a bit. Now at Neo4j, we love Docker. Any Docker users? Okay, quite a few, great. So Docker is a way that allows for bundling software and all of its dependencies in a standard unit called a container. A container is defined by an image. And at Neo4j, we have an official Docker image. So this is maintained by our engineering team. This is available on Docker Hub. So if you want to pull down and run Docker in Neo4j in a Docker container, just Docker pull Neo4j, and you're good to go. You don't have to worry about other dependencies. You can run this within the Docker container. You can deploy this to the cloud. So Docker is really great. But for these polyglot deployments, there's a tool called Docker Compose that is really great. So Docker Compose allows you to define multiple Docker containers and link them together just in one YAML configuration file. So for our course catalog example where we wanted to deploy Mongo, Neo4j, and this Python Neo4j doc manager, this is how we would do this using Docker Compose. So we're specifying one container using the Mongo image. When that starts up, we're just saying that we need to create a replica set. This allows us to tail that transaction log. We're defining a container for Neo4j, exposing the port for Neo4j, and then we have another container for the Mongo connector project, which is this is based on a Python distribution on Ubuntu, and we're linking the Mongo connector container to the Mongo and the Neo4j container. Then when that starts up, we're installing Doc Manager and starting the Mongo connector service. So once we've defined this, it's just Docker Compose up, Docker pulls down all of the dependencies that we need, and we can run this locally. We can deploy it to the cloud. We're good to go. So we've hinted at another challenge of these polyglot environments, and that's around data models. So each database has their own sort of specific type of data model. Graphs databases have the property graph. We have document databases. We have key value stores. We have column family data models. And so translating back and forth between these can be a challenge for us. So let's take Cassandra for an example. Any Cassandra users? OK, a couple. Great. So Cassandra is a column family database. This is fundamentally a different model from a property graph. There's no concept of relationships here. And that doesn't mean we don't have relationships in our data. It just means they're not expressed in the data model. So what if we wanted to pull out some data from Cassandra into Neo4j and take advantage of the relationships in our data? How would we do that? Well, for that, we have tool number 3, the Neo4j Cassandra data import tool. This is another Python tool that uses both the Neo4j and Cassandra drivers. And there's two phases here. The first is inspecting the Cassandra instance and looking at the schema of that to generate what we have up here. So we then apply some basic rules translating the model. The first is that tables become nodes. So we have an artist table there, an artist column family. That becomes a node. We have a track. That becomes a node as well. But if you look here, we have these blank curly braces in this text. So what's that for? Well, this is how we can configure how we want to map the data model from Cassandra, which is column family oriented, to a property graph. So for each one of these, we can fill these in and say, this should be a property. This defines a relationship that we need to essentially join on with another table in Cassandra. This defines an ID field, so create a unique constraint, or we need an index on this property because we want to do a lookup on it. So we fill that in. For our artist and track, it might look something like this. We have some properties. We're identifying this artist relationship, tying the track to the artist. And then with this tool, we can generate load CSV cipher. So load CSV is a tool to very efficiently import data into Neo4j. This is automatically generated based on how we've defined this mapping in our data model from column family to graph. And with these load CSV statements, which are then executed with this tool, we can import some subset of our data from Cassandra into Neo4j and start using Cypher to take advantage of our relationships in our data. So the last bit I want to talk about here, and the piece that I'm really excited about, are updates in Neo4j 3.0 that impact how we can build these types of tools and integrations. So I'm sure you've heard about these throughout the day. Bolt, drivers, and stored procedures. So we'll talk about stored procedures first. Stored procedures are user-defined Java code that's deployed to the database and then callable from Cypher. There are lots of these built in, so we can say call db.labels, and we get back all of the labels that exist in our database currently. I said these are user-defined, and so in the Neo4j contrib GitHub repository, so these are contributions from the community and also from folks at Neo4j. This is a library of awesome procedures, or APOC. I think there are about 102 in here right now, and there's all kinds of stuff in this library. So things like call apoc.metagraph, and this will inspect our database, and this will draw the metagraph, so a graph of our data model. So if we ran that on our movie graph, we can see that person directed movie, person reviewed movie, things like that. So that's useful. One section I want to talk about in particular is how we can load data from a relational database using a procedure. So this is really cool. I think we have time for a demo here. So let's look at a specific example. So this is the Northwind ER diagram. So Northwind, for those who don't know, is sort of the canonical relational example. So this is dealing with customers, their orders, products, employees that fulfilled the orders, things like that. And we're going to focus on just a subset of this. So orders, products, and customers. If we were to import this into Neo4j, it might look something like this. Customer placed an order. Order contains a product. So let's see if we can build this graph very quickly here. So this is an empty Neo4j 3.0 instance. So the first thing we need to do is register the JDBC driver for the relational database that we're going to use. We're going to use the MySQL JDBC driver. So we'll do that. So I should say I have MySQL running locally somewhere here. There it is. So I have Northwind, so you can see the tables I have for Northwind. And so the first step here is to create our product nodes. So we're going to say Cypher call apoc.load JDBC. We specify the JDBC connection string for MySQL, which is running locally. We want the Northwind database. User is root with no password apparently. And we say we want the products table. So then what this will do is stream every row from the products table in Northwind into the rest of our ciphers. So then we can say, okay, create a product node for each row, store the product ID, and then set some properties. So if we run this, okay, we imported 77 products. Let's do the same for orders. This is almost identical, except we're just saying, give me the orders table. So now let's look at some relationships. So order details, which is the next table we're going to look at. If you remember from that ER diagram, order details is this join table that's joining products and orders. So we're going to do a match on the product, match on the order, and then create this contains relationship, so we can say this order contains these products. So run that, 2,000 relationships. Let's import our customer nodes. And then finally, for every order, we're going to find the customer that placed that order and create this relationship placed, showing where the customer placed that order. So now let's see what that looks like as a graph. So here are some products. We can traverse out to see all of the orders that contain that product. We can traverse out to see, okay, the user that's placing these orders, all the orders this user has placed. So that's cool. And this allows us to do things like collaborative filtering recommendation queries now. So for some user here, so for Roland, let's look at all of the orders that Roland has placed. Let's look at the products contained in those orders. Let's look at customers that have purchased the same products. Let's see what else those other customers are buying, and let's recommend those to Roland. We can use the number of paths that we find there as a weight. Run that, and oh, Roland should be buying Gorgonzolo Tellini. I have no idea what that is, but that sounds good. Maybe some sort of pasta. Okay, so that was importing data from relational database into Neo4j without leaving Cypher. So you can see these procedures are really powerful. I think really cool, really going to change how we can build these tools and integrations going forward. So these are just the queries that we just saw just in the slides for reference. The other big update to Neo4j 3.0 was Bolt, which is this binary protocol for Neo4j. We now have these official language drivers in JavaScript, Java, .NET, and Python that implement the Bolt protocol. And these allow us to do things like build this Neo4j Spark connector. This allows us to stream data out of Neo4j into Spark using the Java Bolt driver very, very quickly. Do some GraphX or some in-memory processing in Spark, write those updates back to Neo4j very, very quickly. It also allows us to build embeddable graph visualizations in JavaScript. So the Neo4j browser is great as sort of a workbench, but oftentimes we want to be able to embed visualizations into our application. We want to be able to say this property on a node indicates the size that I want it to be in my visualization. Maybe it's some measure of centrality or importance in the network. The same for edges, we want to specify those. Maybe we want the colors to be grouped by some cluster that we've identified, again, configurable by some node. So this is a project I've been working on, which is built on top of Viz.js, which is a JavaScript visualization tool, and it combines the Bolt Neo4j JavaScript driver, so we can just specify some minimal configuration here. This tool generates the Cypher request necessary to pull this data out. I think I have a quick demo of this here. So this is the Game of Thrones network. So someone looked at all of the interactions between characters in Game of Thrones, and we ran some centrality measures, so basically computed betweenness centrality using Cypher, and we stored that as a property on the node. So that's what's setting the size of the node, so we can see that the most important node is Tyrion, followed secondly by John, and we did a Louvain clustering algorithm again in a stored procedure to generate these clusters. So we can see, okay, these yellow nodes are the cluster around Tyrian. So pretty cool. So again, these are some of the updates to Neo4j 3.0 that really change how we build these tools and integrations going forward. So something I'm really excited to work on. Finally, I just want to mention the place to learn more about any of these tools that I mentioned is neo4j.com/developer. This has code snippets for all of the drivers with some use cases in mind. Also has documentation for all of the tools that I mentioned and a lot more that I didn't mention. Thank you very much.